This presentation will be divided into 3 aspects. Firstly, a video of game trail. The second part will cover various scenarios that may occur during gameplay. And the third will showcase the implementation of different functionalities. In the first level, the little fox can earn points by touching cherries along the way. There are frogs and eagles acting as obstacles that impede the fox's progress. The fox can jump over these obstacles to eliminate enemies. When encountering traps in the current forward direction, the little fox needs to jump forward to leap over deep pits. Upon reaching the endpoint of each level, a prompt will appear on the screen, and by pressing the E key, you can transition to the next level. The logic in the second level is similar to the first one here. We expedite the progression. In the second level, the collectible item for the little fox is a diamond, and the enemy is a dragon. But the logic remains the same as the previous level. Upon reaching the endpoint in the second level and pressing the E key, the game transitions to a success page, indicating the end of the game. Next, let's take a look at the possible scenarios that may occur during the gameplay. The little fox can move left and right and jump. When the little fox jumps, the camera moves along with the fox. In the initial state, the caption in the upper left corner is 0. And when the little fox touches the cherry, the caption changes to 1. When the little fox falls off a platform, the game restarts. The enemy frog defaults to jumping left and right. When the little fox collides with a frog, it will be knocked back. If the collision is on the right, the little fox will be knocked back to the right. If on the left, it will be knocked back to the left. Next, We will show how these functions are implemented. In the Play Controller file, the fox's movements and reactions to collisions with objects are described. The ground movement method controls the player's movement on the ground in response to input from a virtual joystick. It retrieves the horizontal input from the joystick, adjusts the player's velocity based on the input to enable movement, updates the player's facing direction, and triggers a jump if the jump button is pressed while the player is on the ground. Additionally, it synchronizes the player's running animation with the movement, providing a responsive and visually appealing character control experience. YixinDu is a pivotal method in the game, featuring a fox navigating through various challenges. It seamlessly toggles between different animation states for the fox character, including idle, falling, jumping, and hurt, based on the player's actions and current game conditions. To make the animation more fluid, we used an animator. The idle fox will sway slightly when in the idle state. Firstly, add an animator component to the fox game object. In the animator controller, create a new animation state representing the fox's idle state. Named idle, we break down the idle animation into multiple segments. Using the animator's curve editor or inspector window, add a keyframe to slightly alter the fox's position or rotation, simulating a subtle swaying motion. You can check this in the bottom right corner. First, prepare the sprite sheet, including different frames for walking left, walking right, and standing still. Then, add an animator component to the fox game object and create an animator controller. Next, within the animator controller, create animation states for the fox's walking, and assign the frames from the sprite sheet to their respective states. Ensure that there is a separate animation state for each direction. It's important to prepare a sprite sheet that includes frames for the fox's walking cycle. Make sure that the first frame and the last frame are identical to achieve a seamless loop. The on-trigger to D method is utilized for managing collision logic with 2D triggers. When a game object enters an area with a 2D trigger, this method is invoked. Initially, it identifies the type of collision by checking the tag of the collided object. In the case of collecting items like cherries, it performs a series of actions, including playing a collection sound, destroying the object, updating cherry or gen counts, and refreshing the UI display. If the collision involves reaching a death line, it disables the player character's audio component, plays a death sound, and invokes the restart method to restart the game after a 2-second delay. The on-collision enter to D method is used to handle collision logic with 2D colliders. When a game object collides with another collider, this method is called. If the collided object is an enemy, the script of the enemy is obtained. Different actions are taken based on the player character's state. If the player is falling, it triggers the enemy's jump on event, causing the enemy to disappear and the player to jump. If the player is on the left side of the enemy, it pushes the player to the left, plays a hurt sound, and sets the hurt state. If the player is on the right side of the enemy, it pushes the player to the right, plays a hurt sound, and sets the hurt state. The restart method is responsible for restarting the game. It achieves this by reloading the current scene using Unity's Scene Manager. This ensures that the player is taken back to the beginning of the game, effectively resetting the game state to its initial configuration. Then, we will talk about the script of Frog Fixed Update function. This function is called once per fixed frame update and serves as a key part of managing the character's animations. Specifically, It invokes the switch-anim method, responsible for dynamically transitioning between different animation states based on the player's actions and the game's current state. By being called in fixed update, it ensures consistent and reliable animation updates across varying frame rates. Movement function. The movement function controls the horizontal movement and jumping behavior of the character. It checks if the character has reached the left or right boundaries, adjusting the facing direction accordingly. Additionally, it sets the character's local scale to reflect the facing direction. When the character is in contact with the ground, it triggers the jumping animation, adjusting the velocity for both horizontal movement and vertical jumping force. Switch-anim function. The switch-anim function manages the transition between different animation states, specifically handling the transition from jumping to falling. If the character is in the midst of a jump and starts descending, Y velocity becomes negative. It switches from the jumping to the falling animation state. It also ensures a smooth transition by checking if the character is touching the ground and currently in the falling state, allowing for precise animation control during various gameplay scenarios. Pass level is a script designed to handle level progression in the game. In the update method, it continuously checks if the E key is pressed using input get keydown key code.e. Upon detecting the key press, it triggers the loading of the next scene in the build index using Scene Manager, load scene manager, get active scene.buildIndex +1. This script essentially allows the player to advance to the next level by pressing the specified key, providing a straightforward mechanism for level transition in the game. In the game, there are a total of 4 scenes, namely the first level, the second level, the home page, and the completion page, which represents the end of level or victory screen. Other script logic is similar to these, such as the implementation of enemy eagle. The script for the enemy eagle, enemugle, inherits from a base enemy class and implements vertical movement within specified bounds. It utilizes variables like move range and speed to control the eagle's range of motion and speed. The start method initializes upper and lower bounds, while the update method calls the movement function to control the eagle's vertical motion, adjusting its facing direction based on the bounds. This script provides a reusable template for implementing similar enemy behaviors with vertical movement. We just mentioned the enemy class, so let's look at it again. This code defines a basic enemy class, used to represent antagonistic characters in the game. The class includes references to components such as rigid body, animator, and audio source, providing methods to destroy the enemy game object and trigger death animations along with death sound effects. This foundational class facilitates the easier implementation of various enemy types while sharing common functionalities and attributes. After installing the CinemaChain package, select Create Empty to create an empty game object representing the virtual camera. Adjust the settings in the inspector. To achieve camera follow functionality, configuration options include the target object to follow, speed, and more. A final summary of the project. Firstly, using Unity's animator component and curve editor, we achieved a subtle rocking animation for the fox character in its idle state, enhancing the game's liveliness. Secondly, employing Spritesheet and Animator Controller, we successfully portrayed the fox's walking animation, configuring different directional animation states to achieve a more natural character movement. Lastly, utilizing cycle animation techniques, we achieved a smooth walking loop for the fox, creating a seamless character animation in the game. In the game, players control the fox to move and jump, interacting with various obstacles and enemies while collecting cherries and gen. To enhance the gaming experience, we introduced Cinema Chain technology, allowing the camera to dynamically adjust based on the fox's movement, providing players with a better visual experience. Additionally, by pressing the E key, players can switch between scenes, adding flexibility to the game flow. This is my homework presentation. Thanks for watching.